Assalamualaikum and very good morning class. Our topic today is on Fourier transform. Our next section is on Fourier transform or FT pair formula. In order to transform time domain signal xt into frequency domain xf, we have what we call Fourier transform, and the equation is given in equation 8.1, which is capital XF or equal to capital X j omega equal integral minus infinity to infinity xt exponential minus j omega t dt. And if you look carefully, it resembles the topics that we discussed earlier on exponential Fourier series. In order to transform our frequency domain signal into time domain signal, we have what we call inverse Fourier transform, which is given in equation 8.2, which is xt equal 1 over 2 pi integral minus infinity to infinity capital X j omega times e exponential positive j omega t d omega. As a conclusion, the Fourier transform is used to convert the signals from time domain to frequency domain, whereas the inverse Fourier transform to convert the signal back from frequency domain to time domain. If we look carefully from the figure shown in this slide, it shows cyclic relationship between Fourier transform and inverse Fourier transform. We say near symmetry for this figure because the signs in the exponential are different between Fourier transform and the inverse Fourier transform. One has negative sign, another one has positive sign. The figure indicates that Fourier transform GT gives a spectra consisting of a continuous sum of exponential with frequency from minus infinity to infinity. As an example to illustrate the concept of Fourier transform, let us go back to some of the Fourier transform pairs which we will be dealing with in the next future. One of the Fourier transform pair is called rectangular pulse, which we have seen previously in Fourier series. So if we have a rectangular pulse as shown on the top figure, our Fourier transform will be as shown in the figure below. As we can see, it is a continuous signal. The rectangular pulse or the rectangular function is often called as a window. Why? Because when you multiply the rectangular pulse with any signal, it lets some signals through and block others, just like the concept of a window, letting in only a specific view. To illustrate the concept of Fourier transform, let us start with Fourier transform for rectangular pulse. As the rectangular pulse is given the equation in time domain as xt equal to v naught from t minus tau 2 over 2 to t over 2 and 0 otherwise, and the signal is represented in the figure shown in the slide. So we proceed with the solution. First, we put the equation xt for inside the Fourier transform equation, which is into xf integral of minus tau over 2 to tau over 2, the limit. V naught is the xt signals times with the exponential e minus j 2 pi ft dt. And when we do the integral, we have xf equal v naught minus j 2 pi f times exponential e minus j 2 pi f tau over 2 minus e minus j 2 pi f times minus tau over 2. And when we rewrite the equation, we have as shown in the third line. And we know that from the sine equation, we have sine theta equal e positive j theta minus e minus j theta divided by j2. And we can rearrange the answer that we get in the third line into the format of sine theta. Rearranging our equation, so therefore our xf equal v naught sine pi f tau over pi f. And we also know that sine as x equal sine x divided by x. So therefore, let us rearrange the equation into the sine function. And when we rearrange the equation into sine function, finally we have xf equal v naught tau sine pi f tau. And this is illustrated in the figure shown in the slide. As a conclusion, for the rectangular pulse, when we convert the rectangular pulse from time domain into frequency domain, we have a sinc function with the amplitude of the frequency is v naught over tau, and the frequency at which amplitude xf equal to 0 occurs when sine pi f tau equal to 0. It is when tau equal 1, 2, 3, and triple dot. Now, let us compare what happened to the rectangular pulse when we change the value of tau. A, tau equal to 2 seconds. B, tau equal to 1 second. C, we put tau into 20 seconds. And what happened when tau equal to infinity? And finally, when tau equal to 0.1 second. That's all for this PowerPoint. In next slide, we will learn about exponential Fourier series. Thank you.